Hi everyone, in this video we're going to be looking at section cuts on a beam. We're going to take the example of a bridge with a car on. Let's draw this now. So that's my car. Not very car-like, I know. I'm going to say this bridge is 10 meters long. The car itself, 2 meters long. The car itself also is 2 meters. And 6 meters from this side. We can call these points A, B, and C. Oh, and so the car is 1,000 kilograms. Taking G to be 9.8. So first we're going to draw the diagram properly, rather than just this picture. Here we've got pin supports. Then our car is going to just be a force. So the force is 1,000 kilograms times 9.8 gives us 9,800 newtons. For this example, we're ignoring the weight of the bridge itself. We can draw this again. We also have horizontal forces. Sorry, no, because it's pin support, we don't. Oh yeah, no, yeah we do, I'm right, sorry. It's not a roller support. A roller support wouldn't have horizontal. This acts halfway along the car. Now we need to work out our reaction forces at A and C. Sorry, I've got these written wrong. This was point B, and this here, C. So we're going to do this by taking moments about A. That's anti-clockwise moments. So we've got minus 9,800 newtons times by 3 meters plus 10 meters times by this here is going to be our vertical force at B. So 9,800 times 3. Yeah, so we're going to say this implies that 29400 equals 3B times 10. So BB equals 2940 newtons. We'll look at our total vertical. So VB is acting upwards. 2940. We'll have a VA minus that force at C. I'm going to say that all equals 0. Therefore VA (6,860). We've also got the horizontal forces, but there aren't any, so we're just going to say they all equal 0. So we can draw it out again. And we are going to need 2 section cuts. One here, C1, one here, C2. So we're going to take these cuts, go A to C1, we're going to have internal forces. This is a positive face. Oh, that's a bit big. I'm going to call our upwards force Q. We have our moment. We're going to have a normal force. But obviously, vertical force is 0, so we're just ignoring that now. So we're going to just scribble that out. So for here, part 1, this section here, A to C, part 1, section C to B, part 2. So part 1, 0 meters less than X less than 3 meters. Clearly, taking the upwards bit here, Q equals minus 6,860. But we have an internal moment as well, so we're going to take our moment about A. It doesn't matter where we take our moment from. And this cut is X meters along. This cut here can be anywhere between A and C, but not at A or C. So taking moments about A, we've got our force Q, times by x plus our internal moment m. We know our q is minus 6660. X plus m. That's all equal to 0. Therefore, our internal moment equals 6860x Newton meters, newtons per meter. Or no, Newton meters. I'm going to take this again for part 2. Section cut 2 from C to B. Oh, what's it doing that for? I don't want ink to shape on, do I? Part 2. So 3 meters x to the end of the beam, to the end of the bridge, which is 10 meters. So this point here, we've got point B and point C2. At point B, 2940 newtons. And at the section cut C2, we've got our internal forces again, but they're facing the other way, the negative face. So our Q is now acting downwards. Again, we're just going to ignore our normal force because we've got none in the horizontal direction, and our moment is going to act the opposite way. Using the same logic, the downwards, sorry, I need to label them, our Q minus Q because Q is acting down, add 2940, all equals 0, therefore Q equals 2940 newtons for anywhere between C2 and B. And we're going to take a moment about C2. Of course, x now is 3 meters. 3 meters is here, and it's x. This distance, sorry, is x minus 3 meters. So taking moments about C2, x minus 3 meters, because x already goes along for this bit here up to 3 meters. And that will be times 2940. So that moment is supposed to go the other way. So we have minus m, our internal moment, all equals 0. That will give us 2940x minus 2940 times 3 minus 8820 equals m. So that's our internal moment. So we have all the information we need now. We've worked out all the internal forces between A and C and all the internal forces between C and B. Let's highlight these. So I'll just write that out properly. M equals 2940x minus 8820.